Right, today we're going to be looking at high level and low level languages, translators, so to go between these two, and the two types of translators, interpreters and compilers, and all the pros and cons of each of them and their differences. And then obviously I've got the little quiz at the end. Right, so here's instructions in Python. This is a program I've looked at before. You should be able at this point to look at this and think, what does it do? At least roughly, what does it do? So it asks for an age, and if the age is 9 or less, it will say you could play Club Penguin, and if not, it will say it's a bit weird you play Club Penguin if you're older than 9. Now, it's not as easy as English, but kind of building something, it'll be easier than what I'm about to show you in a minute. At this point, you might get errors. This one hasn't got any errors, but as we're getting used to it, you're getting better at spotting errors, and it's becoming easier for you to do that. So Python is what we call a high-level language, and it's because it looks like English words. It's not completely English, but it looks like English. You can write them relatively quickly. Now, it's not quicker than writing in English, but it's quicker than what I'm about to show you. And again, it's easy to edit, easier than what I'm about to show you. Same with easier to find errors, and it's just in general, it's designed to solve problems. So what is it easier than? It's easier than binary. So this is what you used to have to program computers in, nothing but zeros and ones, and it's a bit harder to say, like, what does this program actually do? This compared to this, there's a big difference. So this isn't the easiest thing to understand and you've got to learn it, it's a lot easier to learn a programming language, a high-level programming language, than binary. Before we move on, just one last thing I forgot to say. High-level languages look like English words. That's not just, this is actually worldwide. Nearly every programming language is in English, so you actually get a lot of people in different countries that can program and they can't speak in any English, but they program in English languages. There's only a couple. I think there's a Russian programming language, and there was one other, but I've forgotten it. So yeah, nearly every single programming language is in English. So yeah, this was binary. Another word for this is machine code, because it's what a machine understands, what a computer understands. In contrast to Python, it's quite difficult to read. It would take ages to write, and we're actually going to be looking later at how to write in binary, just write our names. But it does take ages. It takes ages just to write a name, never mind an entire program. It's very hard to edit and to find errors. If I was to tell you one bit was wrong here, it would be quite difficult to find which 0 and 1. You'd have to go work out what each one stands for and all that. Whereas this one, if I told you there was an error here, it wouldn't be quite as difficult. So why do we need a translator? We're learning this in class. We understand a high-level language, Python. It's easy for us to understand, and it's kind of like half English. And the computer only understands zeros and ones, its own little language. So we need something in between that goes from the high-level language to the low-level language. That's where translators come in. There's two types, interpreter and compilers. We use interpreters in class, and I'll just go over what each one actually does. So an interpreter, it translates one line of code into binary at a time and executes it. This is why when you are programming, say in class, it will pop up a little error when it reaches line 4, and it will say line 4 has an error. That's what it's designed to do. It tells you what the error is immediately, and then maybe you fix that error in line 4, and then there's an error in line 6. Well, it'll tell you what that is as well, and it will keep doing it one at a time until you have no errors. So this is really good for testing a program when you're first making it. It will tell you exactly where everything is, and although it can be a bit weird in how it tells you, it will tell you what is wrong with a little error code at the bottom, and you can always just copy and paste that and Google it. A compiler, on the other hand, it takes every single line at once and tries to just make it into a complete program. And then rather than telling you errors at one at a time, it just tells you every error. I have used these in the past. I find them a bit depressing and overwhelming in that if you get one error in an interpreter, it'll just tell you about that one error. But that one error in a compiler can cause errors everywhere, and it will actually return, like, no joke, you've got 940 errors, and then you've got to figure out where they're all coming from, and then maybe you fix one line and that it'll still say you've got 840 errors. It can be a bit overwhelming, and it won't really give you much detail as to where it is. So this is not good for testing. Where it is good, it's good once you've got a working program. So it doesn't, unlike, so when we run a programming class, you have to open up Python first, and then you go edit with idle and you run it. Once a compiled program is compiled, that is it. You don't need to use you don't need to open up Python or anything like that first. You just run it. The way I try and think about this is, if you open up Microsoft Word, you don't go open up Python first and then open up Microsoft Word from there looking at the code. No, you just double click on the Word icon and it will open up. That is because Microsoft Word has been compiled, and you're not really able to see the code, and that's the whole point of a compiled program. A compiled program is when you've finished a program. So what you might actually do is you might use an interpreter for testing it, for developing a program, and then say you want to sell it, say you've made a game or something, you want to download it on Steam, put it on a disk, then you compile it. Problem is, this process, compilation, takes ages, but once you've done it, again, this is why it's not good for testing, because it could take just a few minutes or possibly hours. If it was a massive game, possibly days. So it takes ages, but after that it's quite fast because you can just double click on it and run it. So the differences are, an interpreter is easy to find errors, and it's very good for testing as a result, and you can just jump right into it. However, it's quite slow in that how it finds its line, just relatively slow, because it's going a line at a time, and you need to have this bit here, interpreter software must be present during execution of code. That just means you need to have Python open. Compiler, like I said, where is it? It's very slow the first time you do it, but once you've got all the errors out, once you've got all the kinks straightened out, it is very fast. So it runs very quickly because once it's been compiled, because you don't need to even look at the code anymore. Well, you do, but you don't need to look at it in that context. And it doesn't need to be there. You don't need Python open or anything. So it's important that we know the differences between these two. The one, I've already kind of talked about it, but I've just made a slide for this just in case, because it's quite difficult to get your head around. An interpreter is quite slow, relatively slow every time you run a program, whereas a compiler is dead slow, like excruciatingly slow the first time you compile it, but very fast every time after. Hopefully this PowerPoint has made a bit of sense. I know this can be quite difficult to get your head around. I've actually got a demonstration we'll do back in class. I do it every year. I think it gets your mind working, but unfortunately we can't really do that right now, but we can leave that for another time. If you do need a little bit of extra help, I would definitely recommend watching this video. The video is about 40 years old. It's got all these crazy cartoon characters, and it looks like a bunch of rubbish when it first boots up, But honestly, I would recommend watching that because it's just got such a good explanation of this whole thing. Just shows you in a different context. Right, thank you very much for listening. Bye.